Today's learning target is I can use the Pythagorean theorem to find the length of a side of a right triangle. Today we're going to be using what's called the Pythagorean theorem. Now before we get into specifically what that means, let's take a look at a couple of things. When we're dealing with a right triangle, like we have right here, we call the sides that are next to or adjacent to the right angle, like this one right here and here, these sides are called the legs of the right triangle. And the side that's opposite of the right angle, this one right here, is called the hypotenuse. The hypotenuse is always going to be the longest side of a right triangle. Now this only deals with right triangles, but you can create the right triangle any way you want, and the hypotenuse, the side opposite the right angle, is always going to be the longest side. The Pythagorean theorem is going to tell us the relationship that the legs and the hypotenuse have. So let's take a look at what that relationship is. So the Pythagorean theorem says that in a right triangle, and I highlighted that, the right triangle, because this only works in a right triangle. But in a right triangle, we can take the square of the two legs of a right triangle. So the square of this side and the square of this side is going to be equal to the square of the hypotenuse. So here's the way that looks. We can take a squared, this leg, squared, plus the square of b, this leg, and that's going to equal the square of the hypotenuse. So when people talk about the Pythagorean theorem, you'll hear them say a squared plus b squared equals c squared. That's meaning the legs, the two legs, a squared plus b squared, is going to equal the hypotenuse squared, c squared. So let's use the Pythagorean theorem to find the length of a hypotenuse. So here I have a right triangle, and here's one of my legs, here's my other leg, here's my hypotenuse. So we know that a squared, one of the legs, plus b squared, the other leg, is going to equal c squared. So here's my Pythagorean theorem, a squared plus b squared equals c squared, and now I plug in my numbers. So here's a squared is 8 squared, plus b squared, the other leg, is 15 squared, is going to equal the hypotenuse squared. So I continue solving here, and I know that 8 squared is 64, 15 squared is 225, that's going to equal c squared. So now I continue with my equation. So now I add these together, I get 289 equals c squared, and now I remember to solve for c, I'm going to have to do the opposite. So I want to find the square root of 289, and when I do that on a calculator, that gives me 17. So I know that c, the hypotenuse, is going to be 17, and the label is millimeters. So that's how I can use the Pythagorean theorem to help me find the length of a hypotenuse. Now here's an example where I can use the Pythagorean theorem, but I know the hypotenuse, but I'm going to find one of the legs. So in this case, we've got a balloon tethered to the ground, and it's 40 feet of rope, and I know that it's 25 feet from here to here. I want to find the height. So I'm going to use the theorem, the Pythagorean theorem, and I'm going to plug in my numbers. Right, so I have a squared, that's this one, so I'm going to take 25 squared, don't forget to square it, right? It's not been squared right here, that's just one of the legs. Plus b squared, I don't know what that is yet, is going to equal, now it's not going to equal 40, it's going to equal c squared. So this, the hypotenuse, is 40, but I have to square it because that's what the formula says. So next I square 25, so 25 squared is 625, and 40 squared is 1,600. So now I continue with my equation, I keep writing these out. So this is 625 plus b squared, so I have to do the opposite. I subtract 625 from both sides. That leaves me with b squared equals 975. So to solve for that, I'm going to have to find the square root of 975. And here's what I got when I rounded, or when I did the square root of 975, and I'm going to need to round that. I'll round it to the nearest tenths place right here. So I can see that b is going to equal 31 and 2/10. I'll round it to the nearest tenths, and that's going to be feet. The last thing we're going to do is use the converse of the Pythagorean theorem. So we know now that the Pythagorean theorem says that the legs of a right triangle squared, so a squared and b squared, are going to equal the hypotenuse squared, or c squared. Okay? The converse says that basically we can figure out, if we're given the lengths of a triangle, so in this case here are 3 lengths of a triangle, we can figure out if it's a right triangle by using the Pythagorean theorem. So looking at these 3 measurements of a triangle, 6 centimeters, 8 centimeters, 10 centimeters, we can figure out, is this a right triangle or not? Okay, so here's the first thing we look at. We know that the longest length of a right triangle is the hypotenuse. So this 10 centimeters right there would have to be the hypotenuse. So now let's plug these numbers into the Pythagorean theorem and let's see if it works out. So I plugged my 2 legs in here. Doesn't matter which one I use for a or b. I just went, this one is a squared, so 6 squared plus 8 squared is going to have to equal 10 squared. So once I square those numbers, I get 36 plus 64 equals 100. And now, when I add these 2 together, I get 100 equals 100. Okay, so this is a true statement, 100 equals 100. So I know that, yes, this is a right triangle. Those dimensions would create a right triangle. So I can do the same thing with these numbers over here. I'm going to plug these numbers in. I know this is my hypotenuse, 6 inches, because it's the longest one, so I plug that in for c squared. And I get 16 plus 25 equals 36. And when I add 16 plus 25, I get 41, and I see that does not equal 36. So example B here is not a right triangle.